All right, guys, today we're going to talk about 11.2 surface area of prisms and cylinders. I can determine the surface area of various prisms and of cylinders. So we did a little packet yesterday. We were supposed to do a little packet yesterday about rectangular prisms and cubes. We're going to expand on those definitions just a little bit more. We're going to introduce some new definitions, as well as really focus our attention right here on cylinders, okay? So first of all, let's just, I'm going to draw a real quick little rectangular prism here. Sorry, that's a rough looking sketch, but you get the general idea here. And so what I want you to notice is, let's say that this is 8 meters, and this is 7 meters. And let's say this height right here, let's say this is standing up on its edge, for example. And so this height is 30 meters. What I want you to notice is you have here these two bases right here, the top and the bottom would be exactly the same, right? They have to be. As a matter of fact, we'll go ahead and just put a right angle marker right here just so you know that those are the same. And so again, the bases here, the top and the bottom would have to be the same. And really the base is what kind of defines what kind of shape we have, okay? It's so we have something here that we're talking about right now that is called the bases. What does that make everything else, okay? So what I want you to understand is everything else here, and I'm just going to go ahead and just kind of color this in red. All these other sides, if you will, are actually your lateral area, okay? It's your lateral area. And so if we're talking about surface area, really what I want you to understand is these bases here, again, they are going to be the same. And I'm always going to have two of these, especially when I'm talking about like a rectangular prism, for example. And so notice that really, if I'm talking about the entire surface area, I'm really talking about the total, right? So the surface area here really equals the lateral area okay, plus the bases. But how many of those bases do I have? So I really have two bases. So I'm taking the lateral area here plus my two bases, and that gives me that total surface area, okay? So let me just talk to you about lateral area itself and about how you could actually do that. Well, if this is, in particular, if this is a rectangle and I've got 8 here and 7 here, that means this is also 7 centimeters, and that this also has to be 8 centimeters, okay? So again, the bases themselves, they would be pretty easy to try to figure out. I'm just going to take, for example, and let's just do this. We'll figure out the bases first. So the bases are going to be area equals base times height. And so I'm just going to have 8 times 7, which equals 56. And again, I've got 2 of those bases. So we could take 56 times 2, which is going to be 112 square meters. Okay, so our bases equals this right here. Well, how in the world could we figure out this lateral area? Well, I can look at this as individual little rectangles. Again, but that's probably going to be time consuming. So what I want you to just think about when we're talking about lateral area, okay, lateral area really is P times H. Now you're thinking, what in the world is P? Well, P would be our perimeter, okay, and H, of course, would be our height. So let's just think about this particular one that we're talking about right now. If we're talking about the perimeter of this thing, then I'm going to take this 8 plus the 7 plus the 8 plus the 7 again. So I've got 14 plus 16, which is going to equal 30. So the perimeter of that particular thing, and again, just think about kind of folding this thing out. I've got a top and I've got a bottom, but if I dissected this and I just kind of rolled it out, actually what I'm going to end up with is I'm going to end up with this, okay? And let's just say, for example, these are my 4 sides here. So if I kind of unfolded this box, in essence, this right here would be my perimeter, okay? This is what this This is what this right here would equal. And this would be my height, which is kind of already given right here, right? It's already given me my height. So you notice that my perimeter here, when I fold this out, 8 plus 7 plus 8 plus 7 is 30. And my height, it tells me, actually is 30 meters. So if I multiply those two things together, I'm going to get 900 square meters, right? So again, to find the surface area of this particular object, I'm going to take my 900 meters, that's my lateral area, plus my 112 meters squared, which is my two bases. And again, I'm going to get 1,012 meters squared. You say, well, I don't know if that really helps me or not. I mean, I could just use my rectangular prism formula, and that works just fine for me. Well, it does, but then when you get to other figures, it really makes sense to use this approach here of using surface area equals lateral area plus the two bases, and then understanding that the lateral area is perimeter times height. Let's look at one example here, and in this example, we're just told to find the lateral area. We're not actually looking for the entire surface area, and I'll do my best to try to draw this out here. Let's try to do that again and make it somewhat match. This can sometimes be fun, and sometimes it can be really difficult to try to do, okay? All right, so you got the general idea of what we've got there. Gosh, that is terrible. But in this case, we're looking for the lateral area, and we're told that this is a regular hexagon, okay? What does that mean? That means that every single side here is exactly the same, okay? So again, if we're just looking for the lateral area, which I'll abbreviate as LA, then all I've got to have is the perimeter times the height, okay? So let's say, for example, this height is 13 inches. And let's say that this side is 4 inches. Now remember, all of these sides are exactly the same. So it would be pretty hard to try to figure out what the the lateral area of this would be, unless we just take each one of these little rectangles, which we could do. We could take 4 times 13, and we could multiply that times how many different sides we have, right? But what I want you to understand is that's the same thing as taking the perimeter of this. In other words, all of these are 4 inches, and I have 6 of them. So the perimeter here is actually 6 times 4, which is 24, times the height, which is 13. And you notice pretty quickly I get 312 inches squared. This would be my lateral area for this particular figure right here. So again, it really helps you to be able to figure some of these out pretty quickly. So let's look at another example here, and now we're going to move on to triangles, and then we're going to look at the last one, which is cylinders, which I really want to spend a lot of our time on. So now we have a triangular prism, okay? And I'm going to go ahead and put a right angle mark right here. And let's just go ahead and say that this is 3 feet. And this one is 4 feet. And this one is 5 feet right inside here. And this height right here is going to be 6 feet. So we've pretty much got all of our markings. And again, what kind of prism is this? Well, again, we're going to look at the bases. So the base here would be a triangle. And I'll just go ahead and kind of green those out so you kind of get an idea where those would be. So those are right there. So how do we find the area of a triangle? Well, that's pretty easy. We're going to take half the base times the height. Again, you thought you were done with those formulas, but you're really not. Okay, so that would be half of 3 times 4, which is going to be 1/2 of 12, which equals 6. But now how many of those do I have? Well, you know that I actually have 2 of those because I have a top and a bottom. So we multiply that by 2 again, and we get right back to 12, which is what we kind of had to start with. So I've got 12 feet squared. Almost ran out of room there. Move that over a little bit. Now let's talk about our lateral area. So notice what you're going to have here. Basically, again, you are going to have rectangles, okay? And instead of 4 of those rectangles, you're actually going to have 3 of those rectangles. And again, what I want you to understand is all we need to do here to get the lateral area, because this, again, this is my bases right here. So to get the lateral area of this thing is really just the perimeter times the height. So again, I've got one here that's 3, I've got one that's 4, and I've got one that's 5. See, we're talking about all the different sides of this particular base. And then we're multiplying that times 6. So 3 plus 4 is 7, 7 plus 5 is 12. So really I have 12 times 6, which gives me 72. I do believe. So again, perimeter times height. I've got 12 times 6, which equals 72 feet squared. This is my lateral area. And so I'm going to take my lateral area plus my bases. So 72 plus 12 equals 84 feet squared. All right. So again, let's just go over this again real quick. Surface area equals my lateral area plus 2 times my bases. Okay. Just another way to kind of think about this. So that's really going to play into what we're going to talk about next, which is our last topic for today, which is a cylinder. So think about a cylinder and about how many different surfaces you have. And specifically, I want you to think about the bases that you have here, okay? I want you to think about what are your bases of a cylinder. Well, it makes perfect sense here that the bases of a cylinder, okay, these parts right here are actually a circle. And not just a circle, but 2 circles, okay? So how do we find the area of just a regular old circle? Remember, to find the area of a circle, it's pi r squared. But how many times am I going to do that work? Well, I've actually got 2 circles, and they're going to be identical, right? So I'm going to multiply that times 2. So when we're talking about the bases, okay, my bases are actually 2 pi r squared. So now let's talk about this lateral area, which I will put in red here. This area, what does that actually become? And I want you to think about this. If I were to take, for example, a tube, let's say like a paper towel tube or a toilet paper holder, I know that's kind of gross, but take a toilet paper holder and you cut through the middle of that toilet paper holder, what shape does that actually create? Well, believe it or not, when you fold that out, that actually becomes a rectangle. And of course, I would have to have a height here. I'd have to know how high this is. Matter of fact, let's go ahead and put a number in here. Let's say this is 9 inches. But what in the world does this part of this rectangle, what does this part of this rectangle represent when I fold it out? Well, think about it. If I cut through this particular little cylinder right here and I folded this out, really what I've done is I've went all the way around the circle. What do we call the distance around a circle? Well, the distance around a circle is the circumference. And notice that my formula here already has r in it, so we might as well use the circumference formula that has radius in it, which again is 2 pi r. So this length really is represented by 2 pi r. It's represented by the circumference, okay? So to find the area of this shape right here, this lateral area, I just need to do the base times the height, which is actually 2 pi r times h. Okay, so my lateral area equals 2 pi r h. So again, to find the surface area, remember that I'm always going to take my lateral area plus my bases. Well, I've kind of got that already laid out here. So the surface area of a cylinder, let me just move this down just a little bit, of a cylinder actually equals 2 pi r h plus 2 pi r squared, okay? This would be the formula that I would use to find the surface area of a cylinder. And it makes sense. I'm taking the area of the circles, which again was the green, and I'm taking the lateral area of the cylinder and I'm adding those two things together, and that gives me the total surface area. So let's practice with this particular one. Let's say that I have a radius of 4 inches. So literally all I have to do, surface area equals 2 pi times r, which in this case is 4, times h, which is 9, plus 2 pi, and again r is 4 squared. And I could put every bit of that work into the calculator, or I could just go ahead and leave my answers in terms of pi. That would be fine. So for this first part here, I would have 2 times 4 times 9. 2 times 4 is 8. 8 times 9 is 72. So this would be 72 pi. Plus 4 squared would be 16. 16 times 2 would be 32 pi. And so my final answer here would be 104 pi inches squared. Again, if I wanted to go ahead and do that math all the way out, I could, but if it tells me to leave it in terms of pi, then there would be my answer, okay? So again, pretty simple as long as you've got those formulas. Again, surface area is lateral area plus the bases. In the case of a cylinder, here would be our formula for the cylinder. And then again, for a rectangle, I just want you to think about the fact that perimeter times height gives me my lateral area for most figures. Okay, so this right here is really, really important, as well as that formula for cylinders. So if you need help, make sure that you reach out to us. We'd be glad to help you with this. And have a great day today.